Welcome everyone. Let's talk about polynomials expressions. Definition of a polynomial. A polynomial is a mathematical expression built from variables like x, y, z. Coefficient is the number in front of the variable 6x, 7y. These numbers are coefficients. And the operations of addition, subtraction, multiplication. The key rule of a polynomial is exponents must be non-negative integers. So my power cannot be non-positive. Polynomial examples. Of course, all of these are terms. 3x squared plus 2x minus 1, y to the 7th power plus 6, x plus 5. A polynomial of one term is called monomial, two terms is called binomial, three terms is called trinomial. We have some examples for each. Monomial examples, binomial examples, trinomial examples. It's just because of the amount of the terms we have. Degree of a term. Now we know what a term is. Let's talk about degree of it. The exponent, which is the power of the variable, is called degree. If more than one variable is present, degree is the sum of the exponents. For example, x squared y cubed, degree of this is equal to 5 because two terms you add the exponents. If no variable occur in a term, it's called a constant term. 5, 6, 7. Degree of a constant term is 0. Why? Because if 5 is equal to 5 multiplied with x to the power of 0, I have a hidden 0 here, so therefore degree of a constant term is 0. Example, figure out the degrees. 3x to the 8th power, degree is clearly 8. There's only one variable. We have three variables, we need to add the degrees. Degree is equal to 2 plus 2 plus 2, which gives us 6. Pi, it's by itself, it has no degree. The degree is 0. We cannot say there is no degree. Degree of a polynomial. The degree of a polynomial with more than one term is the largest of the degrees of the individual terms. Example, figure out the degrees of the polynomial. All right, what will we do is, let's see, we have three terms in this polynomial. Therefore, we will check the degrees one by one. Degree of the first term, 4. Degree of the second term, 2. Degree of the third term, 0. The greatest one is 4, therefore my degree is 4. Three terms again. Degree of the first term, 3 plus 2, 5. If it's multiplied, we have to add the powers. Degree of the second term is 1. Degree of the last term is 0. Therefore, the degree of this polynomial is 5. Let's do it without writing it one by one. Degree is 0, 1, 10, 30. 30 is the greatest number, obviously. Degree is 30. X cubed, degree is x cubed. The degree is 3. Degree is 3 because I add. Degree is 3 again. Degree is 3 again. Degree is again. So therefore, the degree is 3. Like and unlike terms. A really simple concept. Like terms are terms that have exactly the same variables and the same exponents. For example, 3x squared, 7x squared. Same variable, same power, but the coefficient can be different, of course. Unlike terms are the terms that are exactly opposite, have different variables and different exponents. It doesn't have to be both at the same time. For example, 6x squared, 5y squared. These are unlike terms. You cannot combine unlike terms. You can add these terms to each other, which gives you 10x squared, but you cannot add these terms to each other. Example, which ones are like and unlike terms? You can try it by yourself. 3x squared minus negative 5x squared. These are like terms because same variable, same power. I don't have to check the coefficient, it doesn't matter. Different variables, unlike terms. Same variable, same power, like terms. Same variables, a, b, but the power is different, so therefore unlike terms. Same variables, same powers, like terms. Addition and subtraction. For addition, we will combine like terms like we just did. 5x squared plus 6x squared is equal to 11x squared. For subtraction, we will subtract them. 6x squared minus 4x squared, which is equal to 2x squared. Examples, 2x squared plus 3x plus 4x squared minus 5x. We have parentheses, but since this is a plus and I don't have any issues with any signs, I can drop the parentheses. 2x squared plus 3x plus 4x squared minus 5x. Let's see the like terms. These are like terms. 6 squared. These are like terms. Negative 2x. 5x squared minus 2x minus 3x squared plus 6x. Now we have to be careful because we need to distribute the negative sign first. 5x squared minus 2x minus 3x squared minus 6x. Let's see the like terms. These two are like terms, which gives us 2x squared. These two are like terms, which gives us negative 8x. Multiplication of these polynomials. To multiply polynomials, you must multiply every term in the first polynomial by every term in the second polynomial. So we will use the distribute property. What was it? A multiplied with b plus c is equal to ab plus ac. Then combine any like terms to simplify the answer. We have one more distributive property, a plus b multiplied with c plus d AC plus, you distribute all over. AC, AD, BC, BD. I don't have enough space for it here. Examples. Let's start with a monomial multiplied by a polynomial. We will distribute, of course, as we said, 1 by 1. 6x cubed minus 10x squared. I'm multiplying 1 by 1 plus 2x. Let's multiply a binomial with a binomial. First term's multiplied, x squared. Then I multiply it with the second term, minus 3x. I multiply the second term with the first term, plus 2x. Last term's multiplied, minus 6. Let's see if we have any like terms. We have. So we will write it in a simpler form, minus 5x minus 6. This can look a little bit long, but it's just doing the same thing, multiplying first terms, x to the fourth power, minus 3x cubed y plus x squared y squared plus 2y multiplied with x cubed, 2y x cubed, 2y multiplied with minus 3x squared y minus 6x squared y squared, and last term is plus 2xy cubed. Let's see what like terms do we have. First of all, there's no like term for this one. Let's clean it. X cubed y, do we have any x cubed y? We have 1 here. Minus x cubed y, cancel. Let's clean this part as well. Squared y squared, which gives us minus 5x squared y squared. These like terms are also gone. This is alone by itself, 2xy squared. A bonus for you, try to solve this by yourself. You will do the same thing. I think you can use, it doesn't matter which way you do it. You can start multiplying from left to right or right to left. Do however you want. Just make sure you multiply every term. FOIL, the thing we just did is called FOIL. I don't really know if there's a reason to name this method, but if it helps, I guess. A plus B multiplied with C plus D. We call this first multiplied with first, then the outer, then the inner, then the last. And like, this can help you memorize the order, maybe, I'm not sure. Special product forms a squared minus b squared, for example, is equal to a minus b multiplied with a plus b. We need to know these because we use them quite a lot. In the future, you will learn something called binomial theorem, which will help you to evaluate some of these faster, maybe. But for now, you can still try to algebraically multiply a plus b with a plus b squared. But other than that, it's really helpful to memorize these special product forms. It's time to talk about the factoring, which is the most important part for us. Factoring polynomials reverses the distributive operations we did. If we cannot factorize a polynomial, we will call it prime. Our common factoring techniques include, you can read it, forms. All right, let's start using these forms one by one. Removing a common factor, GCF, which stands for greatest common factor. All right, that took some time. Let's see. our first term, second term, third term. Let's see what is in common. First of all, I clearly see greatest number that I can factorize is 4. Then I'm looking at the variable. The greatest variable I can factorize is x. So therefore, let's factor out the 4x, which gives us 4x multiplied with x squared minus 2x plus 3. If I'm not sure if this is correct, I can just multiply it back. This gives me 4x cubed. This gives me, there's a minus already. I put negative 8x squared plus 12x, which is equal to this. So therefore, this factoring is correct. All right, I have two terms. Let's see what do I have in common. So first is 4 is the greatest common number I have. There's a x squared minus 1 to the fourth power. There's a cube of it, so we can factorize x squared minus 1 to the third power cubed. All right, what else can we do? Let's see. And there's another cube that I can factorize here. The greatest I can factorize is 3. Let's start doing it. 4x squared minus 1 cubed, 3x plus 1 cubed. How do I factorize these out? It's really simple. I'm just gonna check what else do I need to get the original term. First part, to get the 12, I need to multiply 4 with 3. So therefore, I need a 3 here. Multiplied. X squared minus 1 to the fourth power. It's cubed. I need one more x squared minus 1, so it's the fourth power. This is cubed. This is cubed. I don't need to write 1. Plus. Second part, I have a 8x here. I need a 2x. So when I multiply the first term, I get 8x I need. X squared minus 1 to the cubed again. So I don't need anything. You can write multiplied with 1, but it doesn't change anything. 3x plus 1 to the fourth power. I have a cube here. I need one more 3x plus 1. All good. Let's see what do we get from inside. 3x squared minus 3 plus 6x squared plus 2x, which gives us 9x squared plus 2x minus 3. 4 multiplied with x squared minus 1 cubed, 3x plus 1 cubed. You can, let's multiply this with 9x squared plus 2x minus 3. It's still long, but it's okay. We are trying to learn factorizing. Factoring by grouping. The idea is, from the name you can tell, we will group things. For example, let's group these two terms, x cubed plus 3x squared plus 2x plus 6. Now I want to see what do I have in common. I have an x squared here. X squared, factor out the x squared, x plus 3 plus, factor out the 2 from here, x plus 3. X plus 3s are common. X plus 3 multiplied with x squared plus 2, which is my answer. Reverse FOIL, factoring trinomials. This works for trinomials. This works best for trinomials. How are we gonna do it? First, look at the first term, x squared. I can factorize this as x multiplied with x. Now, the next step is I need to factorize 6 in a way that when you add these, it should give the coefficient of the middle, so which is 7. I will factorize 6 in a way. How can I factorize 6? 1 multiplied with 6 or 2 multiplied with 3. You can 3, 2, since it's 6, x, it's the same thing. If I multiply 1 plus 6 and 2 with 3, I get 6. Now, I need to add 2 of these, so it's 7. Let's add and see. This is 7. This is 5, therefore this is the one I need. 1, 6. From here, you write it like this. X plus 1 multiplied with x plus 6 is equal to, let this be equal to 0. This is also going to be equal to 0. The roots are from here, -1, -6. Special form, x squared minus 16. We said that a squared minus b squared can be written as a minus b multiplied with a plus b. Since this is x squared, and since this is 4 squared, I can write this as x minus 4 multiplied with x plus 4.